A key component of the Math in Focus program is developing skills by starting with the concrete, moving on to pictorial, and finally down to the abstract. This is something we really do a lot with younger kids in elementary school, but when they get to upper elementary, we tend to drop this to the side. And it's really important to still use real objects and have the kids visually see and manipulate the numbers they're moving around. And we're going to see how that can help develop large digit multiplication. Arithmetic problems are generally introduced as word problems instead of being shoved towards the end of the unit, as often happens. This allows the students from the beginning to really think of what are the real objects we have here. That in this case, Roy sells 2,476 of an object, and Anna sells 3 times as many of them. This is an example of a place value grid similar to the ones published in the Math in Focus books. I've taken this grid and filled it up with place value chips. 2,000s, 400s, 7 10s, and 6 1s for 2,476. And since I'm multiplying this number by 3, I make 3 groups of 2,476. Before the students start multiplying, they should understand why they can do that. And in this case, it's because of the distributive property or distributive law, which says that A times B plus C is the same as A times B plus A times C. And the students can see how to extend that to solve 3 times 2,000 plus 400 plus 70 plus 6. When first introduced to large number multiplication, the students would have solved this right here as 4 separate problems. But now we're going to see how we use that in the algorithm. Starting in the ones place, I have 6 groups of 3, which I know is 18. But I know that I'm not allowed to have more than 9 place value chips in one location. So I'm going to have to take 10 of them and put them into the tens column. And then here I can exchange the 10 ones for a single 10. And at the same time, move my 10 over here in my work area up to the top. In my tens column, I have 3 groups of 70, plus 1 additional 10 right here. And 3 groups of 7 means that I have 21 tens in here, plus 1 more equals 22. Going over to my work area, I can write the 2 in the tens place and put the additional 2 right at the top of the hundreds place if I'm feeling comfortable with that now. And again, since I'm not allowed to have 10 or more place value chips in one place value spot, I need to drag over 2 groups of 10 from the tens area to the hundreds area. This leaves me 2 tens left in the tens place, or 20. And finally, I need to replace these 2 groups of 10 tens with 2 hundreds. Fortunately, my numbers are now getting a little bit smaller. I have 3 groups of 400s, which makes 12 hundreds, plus 2 additional ones is 14 hundreds. Just like I did in the earlier places, I'm going to take 10 of them and move them over to the thousand spot, where I'm going to swap them for a single 1,000. And now I'm in the last spot, and I got the easiest problem of all. 3 times 2 is 6, plus 1 more is 7. So 2,476 times 3 equals 7,428. Once students start to understand this concept and feel more comfortable with it, they can start dropping the place value chips and just begin solving the problem using the algorithm. But using the place value chips, you can see how the students build from the concrete to the pictorial and then finally to the abstract. So when they're multiplying the numbers using the algorithm, they have a much stronger understanding of what the work is they're doing and why they're allowed to do it.